Hey guys, it's been a very long time since I've last hopped onto YouTube to make a video, and I think I have something that's worth your stay. So, behind me, I built a new multiplier, and it's based off the mechanics of it are based off of my Fibonacci sequencer machine. This machine can do 2 addition calculations in 1 second, which means that the total multiplication takes 8 seconds for 16 bits times 16 bits. To put that into a perspective, that means you can get a 32-bit output, or yeah, as your max. So let's go ahead and just turn around and see what we have here. So it's using this, the nice thing about this device is, well, one, you can see it's very small, which makes it very tileable, and it infinitely tiles as long as your chunks are loaded and you have this pretty much a beastly computer. I think this machine right here is actually very good just for even this a laptop for the matter, so it's not bad. So the first calculation I'd like to show you is 5 times 5. It's probably my favorite calculation. I don't know why, I just like it. And yeah, you'll see how fast it is. So yep, okay, that's the answer. So that's 16 bits. Also, that is a bit loud, my apologies. But yeah, that's 16 plus 8 plus 1, which is 25, which is great. So that's good. Now this is just to clear the register because, well, even though the register updates on its own, well, it still has some things that happen if you don't update it. Regardless, so now we have to do 15 times 15, which gives me 225. And you'll see that this operation is, again, pretty quick. As you can see, we've got 225 here, which is 128 plus 64 to get 92. And then this is 224 plus 1, which is 225. And that's the answer, of course. And now, let's go ahead and do 255 times 255, which is just 8 bits times 8 bits. So we just add another 4 here. And okay, so that's, yep, you can agree that's 8 bits times 8 bits there. And now I will actually clear the register to be safe, just so that we don't get any errors, and run the beast. And believe it or not, it's, yeah, it is done. It's just that the lamps don't change graphically. It's like a Minecraft limitation. But there's the answer. And I know it's the correct answer because there's 7 lamps on the left, 8 off lamps, and then there's 1 on at the very end. So yeah, that's very nice. And let's go ahead and reset the register. And let's go ahead and do 2 to the power 16, and then minus 1 squared. So that's the same as 16 bits times 16 bits. Okay? And this is the max amount, of course. That's why I have this. It's the max amount. So let's go ahead and do that. And yeah, this calculation only takes 8 seconds, by the way. So let's go ahead and just watch it. Again, my frames lag because I am recording, but they don't lag as much when I'm doing normal stuff. There you go, answer. Yeah, lamps, of course. There you go. So that's the answer. And I know the answer is correct because there's 15 lamps that are on. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then there should be 16 lamps that are off and then 1 that's on. And I know that that's the case because it seems like if you square a number, it basically has this pattern. So like you saw how we had 1 here, and then we had a gap of 4 and then 3 bits. It's basically, the pattern is quite simple. We did 16 bits times 16 bits. So if we multiply it, we get 16 minus 1 lamps on. We get a gap of exactly 16, and we get 1 lamp on. And that's just a pattern that occurs. So you actually can calculate squares of high numbers if you just know that on your own. Okay, so yeah, that's all I really wanted to show you. So what relevance does this machine have? It actually plays a very important role. So actually I have some other piece of hardware that I guess I could show. Now, what is this thing? Well, it's kind of my own Frankenstein machine because what this device does is it takes an angle from 0 to 360 and converts it down to an angle of 0 to 45, and it outputs a flag to depend on which x and y coordinates flip. If you're wondering what this is all about, well, just stay tuned and I'll make the next video about how this will be used. But hey, let's give it a shot, right? So here's what I'm going to do. It does a couple of things. So what it's going to do first is it has a lookup table up here, and it has angles 45, 90, 135, 180, 225, 270, 315, 360, and basically there's a conditional subtractor that checks for the positive. So what it's doing is it's doing the angle minus the lookup table value, and if angle is greater than the lookup table value, then what we do is I take the result from that and I do 45 minus that angle, and then that gives me the proper angle. And also, depending on what quadrant we pulled that number off of, it'll also leave a flag for the use of that. So, alright, let's see, what number would be good? I think I'll do 80. That's a good number to test. So, if you know your unit, well, unit circle, I guess you could do that. But if you know the unit circle for the matter, you know that 80 degrees is just slightly under 90, which means it's in quadrant 1. However, it's above 45 degrees, and the relevance of that is, well, the x and y's will flip if I was to use my thing that I'm not going to tell you about yet. Okay, so let's go ahead and do this. This is actually a 7-second algorithm, so also it's really fast. There you go, and there's our answer. So we get 10 degrees, and the reason why it picked 10 degrees is it said, well, I know that 180 is just above 45 degrees, so what it did is it took 80 minus 45, and we got, let's see, that'd be 35 degrees, and then it took 45 minus that 35, and we get 10. And believe it or not, 10 degrees will correlate to 80 degrees, except the flag here tells us that we picked this off of the top section of the circle. So that's the importance of that. So the idea is I could take this angle, I could take the multiplier and convert it into radians. And yeah, that's where I'll leave that off of. You can comment down below on what you think I'm actually building. But anyways, that's all I have to show for today. Hit the like button. If you want a tutorial on that new multiplier, as you can see, it's very easy to build. Just shoot up a comment or go on the Discord link below and just find my name. I'm Mr. Reman, the Kermit image. And you can friend me or whatever and we can talk. But yeah, thank you. Goodbye.